Hello everyone. Well, now we have done the basics of how to solve a trigonometric equation. And now you are well equipped. I mean, if you wish, you can start solving. Now, this particular session is only to have again, once more, glimpse of how to solve trigonometric equations. I'll be taking only illustrations. Let us see how we solve them. So start with first one as that in minus pi by 2 to pi by 2, how many values of x satisfy the equation cos 6x plus 2 cos square x equal to 1. And then we are given 4 options. We have to pick the right one. Now when I look at this equation, now my choices are that I write that 2 cos square x minus 1 at one place and make right hand side 0. That could be one choice. Or some of you may think that can I write cos 6x as cos of 2 times 3x or cos of 3 times 2x. Now choice is yours. In case you have chosen a wrong option, I mean the method or wrong way, doesn't matter. Rewrite, try again, but that one experience will teach you something. So let me start. I write cos 6x equal to 2 cos square x equal to 1. I mean the standard given equation with which I start. And I write it as cos 6x plus cos 2x equal to 0. Like 2 cos square x minus 1 I have taken and I replace that by cos 2x. Now at this stage, if you wish, you can use cos c plus cos d formula also. Or you can write that cos 6x as cos of 3 times 2x and use formula of cos 3 theta. And that leads to 4 cos cube 2x minus 3 cos 2x plus cos 2x equal to 0. And everywhere now I made 2x only. And by doing this, what I get is actually 4 cos cube 2x minus 2 cos 2x equal to 0, which on factorization gives me 2 cos square 2x minus 1 into cos 2x equal to 0. Now again you have like product of two quantities, make one of them 0 and proceed from there. So I get one option as cos 2x equal to 0 and other could have been 2 cos square 2x minus 1 equal to 0, which is nothing but cos 4x equal to 0. And that gives me that 2x and 4x, they are expected to be odd multiples of pi by 2. So I write 2x equal to 2n plus 1 into pi by 2 and I write 4x equal to 2p plus 1 into pi by 2. And from there I try to write my x. 2n plus 1 into pi by 4. 2p plus 1 into pi by 8. I mean, these are the options for x. And look at that interval given. It is minus pi by 2 to pi by 2. Now, you have to pick up only those angles which are between minus pi by 2 and pi by 2. And they are nothing but minus pi by 4, minus pi by 8, plus pi by 8 and plus pi by 4. So, in all, there are 4 values of x in interval minus pi by 2 to pi by 2, which satisfy the given equation. And hence, my answer is D. Now, one equation was given to you, choice was totally yours. At any stage, if you felt like using cos c plus cos d formula, go ahead and try the entire thing. Take the problem till the end and then make sure that you also get these 4 values of x. Now, I move to further. And second question I take as the solution set of, I'm given equation cos 4th x plus cos 4th y minus x square y equal to 1. And I am given 4 options for the solution set. I'm not reading out all the 4 options. Now realize this, when I read this question, look at the complexity of the equation. Cos 4th x plus cos 4th y, 4th degree equation it is. And please do not dare to write sec square x as 1 upon cos square x and sec square y as 1 upon cos square y. That would increase degree of the equation because cos square x, cos square y will get multiplied to cos 4th x and that will give you 8th degree equation. You are not able to handle suppose 4th degree equation. So don't even dream of solving 8th degree equation. So I am not going to replace that sec square x, sec square y as 1 upon cos square x into 1 upon cos square y. Then what could be other method? The other method is I take that sec square x, sec square y term on the other side and I write equation as cos 4th x plus cos 4th y equal to 1 plus sec square x, sec square y. And that actually finishes the problem. Sec square x, sec square y, these are the terms which are greater or equal to 1. And hence their product also will be greater or equal to 1, but you are adding 1 there. So the entire right hand side would be greater or equal to 2. Left hand side is less or equal to 2. Right hand side is greater or equal to 2. What does that say? To have a solution, left hand side and right hand side both will have to be equal to 2. And that is possible only when cos square x and cos square y both become equal to 1. Now cos square x equal to 1 gives me cos x equal to plus minus 1, and hence x should be some multiple of pi. And cos square y equal to 1 also will give me y equal to some multiple of pi. So my answers for x and y are m pi and n pi. Now look at the correct option, and the correct option is A. Now understand one thing, that taking sec square x, sec square y on the right hand side, I mean this is as simple as this, that if you do that exercise, the entire problem reduces to nothing. But then how many of you think of this step? That God only knows. Keep practicing, such ideas will start coming to your mind also. Now let me move to the third one. And the third one is that x, y, z all belong to 0 to pi by 2, and two equations are given. Tan square x plus cot square x equal to 2 sin square y, and sin square y plus cos square z equal to 1. Question is regarding the number of solutions x, y, z to the system is, and then you have been given some 4 options, and the correct one we will pick up. Now when I look at this equation, first of all there are 3 unknowns x, y, z. Generally I would have expected that there have to be 3 equations for 3 unknowns. So are we short of equations? I mean, are we short of some data? No. I mean, if this question is asked, means there has to be some hint hidden in the problem only. Now understand this, if you read those equations carefully, you will realize that tan square x plus cot square x, this is of the form t plus 1 upon t, and we have already done that. T plus 1 upon t is greater or equal to 2 for t greater than 0. And tan square x, cot square x both are positive quantity. So left hand side is greater or equal to 2. And right hand side is less or equal to 2. To have a solution, we must have tan square x plus cot square x equal to 2 and sin square y equal to 1. And sin square y equal to 1 tells me that sin y will have to be plus 1. And tan square x equal to 1 also tells me that tan x will have to be plus 1. We are not taking negative values, as x and y both are in 0 to pi by 2. Fine. Now we have not yet tried what is z. Mind you please, both values for x and y we have obtained from the first equation itself. I mean, one equation was sufficient to answer for x and y. Now when sin square y is 1, that information I will be using in the second equation. And from tan x equal to 1, I have found x equal to pi by 4, and sin y equal to 1, I have found y equal to pi by 2. Now use this information of sin square y equal to 1 in the second equation, and that will lead to cos square z equal to 0. That means cos z is 0, and hence z equal to pi by 2. So the only answer is x comma y comma z equal to pi by 4 comma pi by 2 comma pi by 2. So there is only one solution to the equation, and hence the correct answer is B. Now see, this question also belongs to trigonometric equations, this topic, but treatment given is so different from those general solutions what we had in the previous sessions. So what I mean is, be alert, be attentive, read the question. Whatever new method comes to your mind, apply that and make sure it takes you to your final destination. Nowhere in the question it is written by which method you have to solve. I keep on repeating this so that you come out with new and new methods. On your own also you can derive. Now I move to the next one, and the next one is the solution set of, and I have taken now trigonometric inequation only for practice. Tan x greater or equal to 3 cot x. An interval for x is given as minus pi by 2 to pi by 2. And the solution sets 4 options are written there. When I look at the inequation, I realize that I need to rewrite it. And I rewrite it as tan x minus 3 upon tan x is greater or equal to 0. Usual simplification you can make. You will have tan square x minus 3 upon tan x greater or equal to 0. That tan square x minus 3 can be factorized as tan x minus root 3 into tan x plus root 3 upon tan x greater or equal to 0. Recall your inequations part, what you have learned in your basic algebra. And from there, also you can answer. And at the same time, please keep in your mind that what type of graph we have for tan x in the interval minus pi by 2 to pi by 2. This will help you to choose answer for x also. And I realize that x will have to be between minus pi by 3 and 0. And this is one option. And the other option is that x can be greater than pi by 3. I mean, I am trying to club three things. One, that inequation written. Second, the graph part. And third, that method of intervals, what you have learnt in linear algebra. And from there, I get my solution set as that x has to be between minus pi by 3 to 0, union pi by 3 to infinity. I'm clubbing three things here. One, the inequation. Second, the graph. And third, method of intervals, what you have learnt. Remember one thing, your interval for x is given as minus pi by 2 to pi by 2 only. And hence, I write my solution as minus pi by 3 to 0, union pi by 3 to pi by 2. That would be the answer. And the correct option is C. Now, all four questions were different. This fourth one was trigonometric inequation. Don't get scared of inequations. I mean, if you know inequations, how to solve, you can solve trigonometric inequations also. I mean, this was just a glimpse. Other questions, other types, those standard methods, you will get in many books also. You can solve those questions. But whatever we did in this particular session, those questions were not the standard ones like finding general solutions. But they come under the category trigonometric equations. I hope you are enjoying all these sessions on trigonometry. I again advise you, keep revising things right from unit circle and graph to all those formulae. And then you will have your sessions more enjoyable. I'll meet you again in next session with more problems. Till then, thank you. Stay tuned.